Today we're going to talk about timers and two use cases tied to our radar system at the top of the screen. So a long time ago, I had found a radar system tutorial built on the God of War style tutorial, and I had used that in previous development, and I migrated it over to the Lyra starter project. And when I did that, there's a couple of things that are unique about Lyra and how assets are loaded in using the game experiences that I had to make some tweaks and adjustments. And I thought it would be good to use that as an example of two examples of when to use a timer. So at the top of the screen, we have a radar compass, and there are a series of points of interest that are on the compass. As I turn around, you'll see there's one behind me, and it gives us the distance. It's 23 meters away. And if I move here, that one's 25 meters away, and this one's 56 meters away. And of course, as I move, those distances and the areas change as I get closer and closer to a particular point. And so there's two timers that are being used, or two sets of timers being used. The first set of timers we're going to talk about is how we manage startup to make sure all the subcomponents of the system are properly linked together based on the Lyra workflow. And the second one is the timer we use in order to constantly update the distance and location of the marker using the least amount of resources. And so let's stop and take a look at the components. We'll talk about each of those, and then we'll look at the code. The radar system itself is not that complicated. First, it is an entirely client-centric piece of the solution. There's no activity going on the server. This is all designed for the player's convenience and sort of cosmetic look and feel. The system is divided into three basic elements. There are marker components that are either placed in the world if they're static, such as a town or a city or a location, or spawned in as needed if they're a quest objective. So they can be there at the beginning of the world, or they can be added throughout gameplay. The main heart of the system is the radar system component. It is added to the player controller via the experience. And there's a radar widget that's added to the HUD also via the experience. And that radar widget manages the directional widgets, the compass indicators on the widget, as well as any markers that might be either quest or location centric. And the first part of where the timers come into play is each of these elements need to know about each other's existence in order to communicate with each other in a seamless fashion. And so the marker component needs to be able to find the radar system component, and the radar system component needs to be able to find the radar widget. And we attempt to do this without hard linking them together. And we're going to use a timer to find those references in the world. And the reason this is the way we have to link them together is in our typical Lyra experience setup, we're not adding the radar system component directly to the pawn like we would have in a sort of non-Lyra structure, right? In a non-Lyra structure, we would add the radar system component directly onto the pawn, and then we knew that at that point, as long as there was a pawn or controller, as long as the controller was there, then we could safely assume that the radar system component was also there. Due to timing issues in the way that these components are added to the various actors in world, we have to deal with that latency of time between the player controller being created and the radar system being added to the player controller. Similarly, because the widget system around the HUD is focused on adding widgets to slots, and you'll see here at the bottom of the screen, we're using the team scores slot, which is at the very top of the HUD, and we're adding our radar widget via the startup logic that adds widgets to the HUD. So there's basically no guarantee of sequence of these things triggering, and there's no guarantee of sequence between when actors are spawned into the world, either through level startup or any other mechanisms, and the addition of these components into our game framework. And so that's the challenge that we need to solve for. So let's use the radar system component and the radar widget as an example of how we might solve for this disconnected startup sequence. One might think that the optimal way is to use a delegate and to broadcast that you're up and ready. The challenge with having the system component come up and then broadcasting that it's ready is that assumes that the widget is also up and listening for that delegate event. So we have the situation where we don't know the sequence of them, so we cannot create a dependency where I broadcast that I'm ready and you pick that up and you do the processing that you need to do. So in order to make this connection most effective, on the radar system component, once the system component is registered on the player controller, we can safely determine if the actor that this component was added to is in fact a player controller. If it's not a player controller, we can exit out of here and not process. So this would be a case where we're just trying to catch where someone put the component on the wrong type of actor. So if it's not a player controller, we can issue a warning message and abort logic from this point on. Assuming we are on a player controller, we can make an attempt to find the radar widget. So the first thing we do is we say, okay, is there a radar widget out there? If so, we can safely initialize the radar because we have both the player controller and we have the radar widget. If we don't find the radar widget, which would be the scenario where the player controller was created first, but the widget has not yet been created, then we fire off this timer. And so this timer is basically going to go poll to see if the radar widget is there every 1 second. And so every second it will wake up. It will say, okay, is the radar widget here now? And if it is, it'll continue its processing. If not, it'll continue to loop. So we've set up a situation where our preferred path is that we actually find it right away, we initialize, and we never even create the timer. In the event that that doesn't happen, we create our timer, which is this polling right here. And we basically poll once a second to see if the radar widget can be found. If it is found, we do our processing and we clear our timer. So we end that loop. If it's not found, we just continue to poll and we'll just keep polling until that radar widget is found. The only other thing we need to do is make sure that if we destroy the component before the widget is found and the timer is canceled, we're going to go ahead and clear that timer upon component destroy. Ideally, that timer gets cleared here when we get a widget, but on an edge case, we may end up destroying the component before the widget is found, and therefore we clear the timer here. So that's an example of how you might tie two elements of your game together. And then on initialization, which is very similar, so when we do the initialize radar, we're basically doing some logic that assumes that both the player controller and the radar are up and running. The marker component, the one that is placed into the world either at level creation or through gameplay, has a similar logic. It's slightly different, but follows the same design paradigm. So in this case, upon begin play of the marker component, we once again make an attempt to see if we can find the radar system. And if we fail to find the radar system, we set our timer and start looping. So if the radar system is found upon creation, meaning it was already there, we do nothing. If it wasn't, in other words, our cached radar system comes back null, then we're going to go ahead and start the timer and start polling. In the polling system, we need to check two things in this scenario. One, we have to check that we actually have a local player controller, because this marker is in the world, and it may not be, this may be run on a server, it may be run on a client. So if we're getting a local player controller and we get a response from that, we know we're on a client. We then can take that local player controller and determine if that local player controller has a radar system on it. And then the third check to check is, does that local player controller, who we know has a radar system, does it also already know about the radar widget? So this is where I'm checking that all three conditions exist, in which case I will go ahead and continue processing. If those conditions don't exist, then we will we'll poll again 1 second later. And we've set up a maximum polling duration. This is currently set to 120 seconds. Basically saying, look, if there's a marker in the world and it hasn't found a local player controller, and it hasn't found, or it's found that, but it hasn't found the radar system, you might as well stop polling, because after 2 minutes, it's unlikely that you're going to ever find one. So that's just saving some performance. So these two scenarios are how we link the three components together, not knowing the sequence of which any of them are going to occur. So in the case where this actor is spawned into the world, it's highly likely that the polling will never occur. It will simply go grab the radar system from the actor, or from the player controller. Our next use case for the timer is when we're going to update the visual on screen as a result of the changing world. And there are three basic scenarios that we could consider for this. The first, which you see a lot of times being done early, when people are early into Unreal, is to go ahead and tack that on tick, and go ahead and update your UI visuals every time it ticks. The problem with that is tick is firing multiple times. Tick is firing at every frame. And so as your frame rate increases, so does the number of calls to this logic that you're performing. And what ends up happening is, at a high frame rate of 120 frames per second, you end up consuming 4 times the resource load that you would at a 30 frames per second. And so that's kind of a waste. It's also a waste to update that icon on the screen 30 times per second or higher, because your eyes aren't going to pick that up, and there's not enough movement in that piece of information that would be beneficial. At the bottom of the screen is another method. That is when you move the character or you rotate the character. So you hook into the character movement controls and say, anytime this character moves forward, backwards, left, or right, or anytime I rotate the camera, my view plane, go ahead and process the logic. The issues with this approach is one, it's an inconsistent resource consumption, so it makes benchmarking and performance tuning a little more difficult, because depending on how rapidly I move the mouse around or the keyboard, I'll get different consumption rates, and I could lead to sort of lag and choppy resource consumption. It also has the downside of the most resources are going to be consumed when you're frantically moving, which typically is things like combat. If I'm in the heat of combat and I'm moving left and right, I'm firing and rotating, I'm probably less interested in the radar widget at the top of the screen, and I'm more interested in what's happening right around my character. So the most resources are being consumed at the worst possible time, and the resource savings is basically when you're idle, and that's the time when you need to save them the least. So the balance of those two is the use of timers. And the nice thing about using a timer for something like this use case is that you have the flexibility of how frequently you want it to run. And you can fine tune and balance the resource consumption with the smoothness and frequency of which the UI is being updated. And so if you think about a 0.1 second timer interval and a game running at 30 frames per second, that means we're going to update the icons every third frame. So 2 out of the 3 frames we won't update it, the third frame we will update it. If we move to 60 frames per second, we actually get a performance improvement, right? Every 6 frames, we're going to update the widgets on the screen. And then if we move to 120 frames per second, then it's every 12 frames. And so as frame rate increases, we actually save more resources, which can then, of course, be reallocated to other things that are more valuable in the game. And so where tick is an overconsumption of resources and scales in the wrong direction, the movement and the rotation introduces inconsistency and resource load at probably the worst possible time. The timer is a nice balance because it uses just enough resources, it updates the visual for the player to see, and it's very consistent. So back in our code in the radar system component, after we're done polling for the various components at startup, we triggered this initialize radar logic, which did a few initialization items, but then started a second timer. This second timer is set on a more frequent basis. Our polling was set every 1 second. For startup purposes, this is going to poll every 10th of a second. And what it's going to do every 10th of a second is it's going to call our tick radar function, which will then call 3 basic subfunctions, right? The first one is to update the marker distances. So it takes logic that says, okay, where is the player in relation to the markers and how far away are they? Then it will update the marker positions on the radar. And then finally, it'll update any of the directional widgets, the north, northeast, south, southeast. And so it'll perform those 3 functions every 10th of a second. As I said earlier, we also have the onPlayer turned or onPlayer moved, which is an alternative way of deploying this where you tag onto your work stream that says every time I'm moving the player forward or every time I'm rotating the player camera, then I could call the onPlayer turned and onPlayer moved. And onPlayer turned, we would only need to update the directional widgets and the marker positions. And onPlayer move, we would only update the marker directions and the marker positions. So technically we might save 1 function call in that, but as I said earlier, the performance implications of that in combat and when you're in a lot of things are happening, it's far more expensive than if we just simply tick every 10th of a second. And so every 10th of a second, these are happening. They're going to call our various functions for updating the marker position. So we go through and we make sure the markers are in the right positions. We'll update the directional widget and shift those where they need to be. And then we have a variety of sort of helper math functions. But the important part of this piece is sort of 2 use cases of when to use timers, right? One, upon startup when you're unsure of the sequence of things that are going to happen. And secondarily, when you want things to occur, but you don't want to use all the resources that you would on tick, timers are a nice way to allow you to set your own frequency and how much resources you want to allocate to a certain game feature. So hopefully that helps you think about some scenarios where you might use timers, and specifically in the startup logic of Lyra, where I know it can be extremely frustrating when references are not found in your sort of begin play flow. All right, thanks for watching.